Let's get some practice using Newton's laws with kinetic friction. In this case, for example, let's just take a normal box that we want to push around. Let's make it a 5 kilogram box, and let's push on it with a force of 20 newtons to the right. And let's say that the coefficient of kinetic friction is 0.15. And just for fun, let's put a big helium balloon up there. And let's say that that helium balloon provides a force of 10 newtons, a buoyant force of 10 newtons. All right, so there's our problem. Let's say we want to calculate the acceleration of this box. In fact, let's add in some kinematics. So let's figure out how much time does it take for the box to travel 4 meters if this forces are happening continuously. So the question is time to travel 4 meters. Okay, so how do we start this? What's our first process? As always, we want to be thinking about coordinate system. So our coordinate system, since the box is probably going to be moving to the right, let's just make a regular XY coordinate system and use that. Draw our free body diagram. So first step, coordinate system. Second step, free body diagram. So here's my box over here. What are all the forces acting on that box? We have mg, the weight of it is pulling down. Pulling down, excuse me. We have this 20 newtons, which is pushing the box to the right. We have this helium balloon, which is 10 newtons pulling the box up. We also have the normal force, the force of the table or the ground pushing upwards on the box. And finally, because we have a kinetic friction, we know that friction will oppose the motion, so we have force of friction pushing it to the left. So those are all of our forces, and if we look at all of those forces in our coordinate system, we're now able to say, oh, this is our coordinate system again, x and y. We can now write down some of the forces in the x direction and some of the forces in the y direction and apply Newton's law. So what's going on in the x direction? We have a positive 20 newtons, and we have a negative force of friction. That's it, equals mass times acceleration in the x direction. What's going on in the y direction? We have a positive F normal. We have a positive 10 newtons from the balloon, and we have a negative mg from the weight, and that's it, equals mass times acceleration in the y direction. So there's everything we know. We have our coordinate system, we have our free body diagram, and we have our 2 equations of motion. Now we can start thinking, plugging in, figuring out what we want. In order to move forward, let's just figure out what we know. We know that this box is going to be moving to the right. How do we know that? How do we know excuse me, that this box is not floating upwards because of the balloon? Well, if we actually calculate here, if we look at this mg, m is equal to 5 kilograms, so mg is 5 times 9.8 is 49 newtons. 49 newtons is the weight. The balloon only provides 10 newtons, so the balloon's not going to be enough to overcome the weight. It won't float away, which means that the acceleration in the y direction is going to be 0. The box is only going to be moving along the x direction. With that in mind, we can immediately solve force normal is equal to mg minus 10, or it's going to equal to 49 minus 10 newtons, or equal to 39 newtons. This will be useful for us later as we are calculating the friction. We go over here to this x equation, and we end up with 20 newtons minus force of friction. Let's remember, force of friction is equal to mu times F normal. So we can make that substitution, mu F normal. That's it, equals mass times acceleration in the x direction. And now everything we have is numbers except the acceleration. 20 minus mu, which is up here, 0.15 times F normal of 39 equals mass, which is 5 kilograms times A in the x direction. So this is just turns out to be a number. We plug all that stuff into our calculator, and we get 20 minus 0.15 times 39, and then divide that by 5, and we get an acceleration in the x direction of 2.83 meters per second squared. Okay, so we found the acceleration of the box, and now we have to go back to our original question. How much time does it take to travel 4 meters? Well, this is a kinematics problem, v0, v-a-t, delta x. We know our acceleration, 2.83 meters per second squared. We want to travel 4 meters. So we are looking for time. We either need to know the final velocity or the initial velocity. So in this case, we will make the presumption that we started from rest. Initial velocity is 0 meters per second. And now we can find time. We know v0a delta x. So delta x equals v0t plus 1/2 a t squared. 4 is equal to 0 plus 1/2 times 2.83 times t squared. So t squared is equal to t squared is equal to 2.83, and square root t is equal to plus or minus 1.68 seconds. So that's how much time it takes. One thing to note, this 2.83 right here is an acceleration. This 2.83 is a time squared. That's just blind luck. That's a coincidence that those are equal. Those are not the same number.